Okay, let's get ready for today's notes. I believe this is notes number 9. And we're going to talk about inequalities, and we're going to learn some new notation. So do you have your notebook? Do you have your pencil? Do you have your glasses? As you guys know, from all the years of math, when you're doing math, you really do need your glasses because they help with division. Okay, well, I have my glasses and I am ready to go. So let's talk about symbols that mean include the number. So if you're looking at inequality symbols, if you have less than or equal to or greater than or equal to, you include the endpoint because of the equal sign. Of course, also the symbol equals means include the number. There are some other symbols that mean the same thing. If you're graphing and you want to show that you're including the endpoint, you use a closed or filled in circle. And then what we're going to learn today when we learn about interval notation is that if you use square brackets around numbers, that means you're including them. So then symbols that mean exclude the number would be if we just had a less than or if we just had a greater than without the equal to. And if you were graphing and you didn't want to include the endpoint, you would make an open circle instead of a closed circle. And then with interval notation, instead of square brackets, you would use round brackets if you're not including the endpoints. Now sometimes we include one endpoint and not the other, so one of them will be round and one of them will be square. Okay, what we're going to do is take a look at some examples of set notation, and then we'll write their corresponding interval notation, and we'll also draw the graph. So suppose we have x equals 3. I'm going to graph that on a number line. Not being terribly specific about my number line, just make sure that 3 is on there. If you want to represent x equals 3, you just have a closed circle on the 3. Now there's actually no way to represent it with interval notation because an interval has infinitely many numbers in it. So let me go back up here and talk about intervals for a minute. Intervals contain infinitely many numbers. So for example, if you had the interval from 1 to 7, now right now that might look to you like an ordered pair with an x coordinate of 1 and a y coordinate of 7, but that's not what we're doing right now. We're using the same symbol to mean something else. So if you had the interval from 1 to 7, that means all the infinitely many numbers between 1 and 7. So 1.1, 1.2, etc., 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 6.9, 6.99, 6.999, 99999, but not 1 and not 7. Everything between 1 and 7. And if you had the interval with square brackets around the 1 and the 7, it's everything between 1 and 7, including the 1 and including the 7. So you see why we really can't express x equals 3 as an interval. So let's move on. Suppose we have x is greater than 3. Well, the graph, because it doesn't say greater than or equal to, it just says greater than, we're not including the 3, so we put an open circle on the 3 and then an arrow to the right. And I usually like to draw my arrow a little higher because it makes it stand out more, but you can draw it directly on the line. Sometimes I see that graphed like this with a round bracket on the 3 and an arrow to the right for greater than. So in your book, instead of the open circle and the closed circle, it's possible that they're just going to use the round bracket or the square bracket. And then to write this in interval notation, so everything greater than 3, we start with 3, but we don't include it, so round bracket, and then we go to infinity. You always have a round bracket on your infinity, never square, because infinity is not a real number that you can reach. You can't include it. Okay, let's take a look at x is greater than or equal to 3. So for the graph, it's going to look a lot like the previous one, except we are including 3. So we want a closed circle on 3 and then an arrow to the right. Or if we're using the other kind of notation, it would be a square bracket on 3 and an arrow to the right. So then for the interval, we're going to put a square bracket around the 3, and then it's going to infinity, but still round bracket on infinity because we cannot include that. It's not an endpoint. Okay, x is less than 3. So we're going to the left this time on our number line, not including 3. So open circle again. Or if you're using brackets, round bracket. And then for the interval, 3 is the highest number, and then we're going below it. So if you go infinitely far below 3, you're going toward negative infinity. So we have round bracket, negative infinity to 3, round bracket. Always put the lower or farther left number first, comma, the higher or farther right, comma, number second. So lower number, comma, higher number. And then for the next one, we're including the 3, so negative infinity to 3, square bracket on the 3, and closed circle on the 3. Or square bracket on the graph. And then the last 3 here, I'm actually going to save for next time. Next time we're going to talk about absolute value. Okay, for all real numbers, we can talk about that. So all real numbers would be the interval from negative infinity to infinity, round brackets, and then in terms of the number line, you can put some numbers on here if you want. We can put 3 on there if we want, but it's going to be the entire number line. Make sure you make sure that you show that you've graphed something. You don't want to just leave it blank, because leaving it blank like this would make me think it was no numbers at all rather than all real numbers. So make sure. Okay, let's move on. So we're going to be solving some inequalities. The first couple of inequalities are just what we call linear inequalities, x to the first power. And so if you recall, you solve these just like you would solve an equation, except if you multiply or divide by a negative. Remember what you do? People like to say it this way: switch the sign. Another way to say it is reverse the direction of the inequality. So let's keep that in mind as we solve each of these. 3 minus 4x is greater than or equal to 2x plus 8. So we want to get the x terms on one side. So suppose I decide to add 4x to both sides. So 3 is greater than or equal to 6x plus 8. Subtract 8 from both sides. Negative 5 is greater than or equal to 6x. And divide both sides by 6. Negative 5/6 is greater than or equal to x. I divided both sides by a positive, not a negative, so I didn't switch the sign. I don't really like having my answer with the x on the right, so we can just rewrite it backwards. X is less than or equal to negative 5/6. Now suppose that you had actually done your steps in a slightly different order, and suppose that you had subtracted 2x from both sides of the inequality, so you would have 3 minus 6x is greater than or equal to 8, and then you subtracted 3 from both sides, so negative 6x is greater than or equal to 5, and then you divided both sides by negative 6. Because you're dividing by a negative, you reverse the inequality, so now we have x is less than or equal to negative 5/6. So that's the same answer. As long as you're using your algebra correctly, you can do it either way, and the answer should turn out the same. Okay, problem number 2 is known as a compound inequality because we have 2 inequalities in there. It's all strung together. It's basically an and statement. So 6x minus 1 is squeezed between, 6x minus 8 is squeezed between 1 and 4. So the way to solve this is either to keep it all together or to break it up into 2 problems. So first I'll show you keeping it all together. Keeping it all together, we're going to add 8 to all three because we're trying to get x by itself. So we have 9 is less than or equal to 6x is less than or equal to 12. And then divide all three of them by 6. So we have 9/6 is less than or equal to x is less than or equal to 2. Simplify that, and we have 3/2 is less than or equal to x is less than or equal to 2. I kind of forgot about graphing on the last one. So for graphing on this one, I'm just going to make a quick sketch. We need to have 3/2 in here somewhere, and we need to have 2. How about 0, 1, 2? We've got equal signs on both of these, so closed circles, closed circle at 3/2, closed circle at 2, and then a line segment in between. Okay, the other way to do this problem is to break it down into two. So take the first part, the left side and the middle, and make that one inequality. 1 is less than or equal to 6x minus 8, and take the right side and the middle and make that another inequality. 6x minus 8 is less than or equal to 4, and then we solve each of those. So add 9 to both sides, divide by 6, x is greater than or equal to 3/2, and then for the other one, add 8 to both sides, divide by 6, x is less than or equal to 2, and having and in between is really important because if it's and, it means that both things have to be true. X has to be greater than or equal to 3/2 and also less than or equal to 2, and the only way for that to happen is in between them. And just to go back to number 1 real quick and make the graph, so you don't have to really take a whole lot of time on this, just make sure your number's there, and then maybe something else to the left and right. And then because we have the equals on there, we're going to make it a closed circle, and because it's less than, we're going to the left. Okay, now for the next part of the lesson, we're going to learn to solve quadratic, see the x squared, quadratic inequalities. And the process is actually quite a bit more involved and complicated. So I'm going to pause and end this part of the video, and then I will start part 2.